Okay, so in this video, I will show you how to perform basic data processing and data visualization creation using Tableau. You can first log into your account on the Tableau public website and start by creating a Create a Viz, which will lead you to the web interface for Tableau. Then you can start connecting to the data and creating data visualizations. In this example, I'm trying to replicate an interactive visualization from the Gapminder website. On this visualization, you see life expectancy on the y-axis and GDP per capita on the x-axis, with the size of the circle representing population. You can filter different countries on the right panel. So we're going to simulate this visualization in Tableau. I'm going to first try to load the data by connecting to the data source. I'll drag this life expectancy data into the data connection panel, which will establish the connection to the data source. You'll see the connections here, as well as the data canvas, where you can relate multiple tables, and the data overview at the bottom. If you look at the data overview, you'll notice it's not actually using the first row to create columns. To fix that, click Field Names on first row on the context menu. Now you have the correct columns. Also, you'll notice that the years are in a wide format. We need to convert that into a long format by pivoting the columns. We will rename the pivoted column to year and change the data type from string to number. We will also rename this to life expectancy and leave the data type as it is. Next, I'm going to load another data set, in this case population. Drag the CSV file into the Files panel, sharing the same connection as before, then drag this CSV as a new base table. The columns look fine, but we're going to convert the years into a long format again. When renaming the pivoted column, you cannot have the same column name in the same data canvas, so it has to be a different name. I'm going to name it year population and change the data type from string to number. This numeric column should be population. However, as you see, this population data has string characters like M. Sometimes it can be K, sometimes it can be B. K represents 1,000, M represents 1 million, and B represents 1 billion. Since it's in string format, we want to convert this into a number format. We will create a new calculated field to transform this string into a number. The logic is pretty simple. If it ends with K, we're going to multiply the number portion by 1,000. If it ends with M, we're going to multiply the number portion by 1 million, and so on. I'm going to name the new field as population number. We will use this field for creating a visualization. Next, we're going to load the final file, which is the GDP file. Drag this GDP CSV as a new base table. You'll notice that it suffers from the same issue. Again, we will use the first row values for columns and pivot these years into a column. Rename the pivoted field name to year. You cannot have a duplicate name, so it's going to be year GDP. And convert the data type to number. This column should be named as GDP. Same as before, we're going to transform this column using the same formula. Then we're going to name it GDP number. Now we are almost done with the data processing. Just want to make sure the country is recognized as a string, not a number. The earth mark represents that this is geographic data. Okay, everything looks good. Now we are almost done with the individual tables. On the data canvas, we're going to relate these tables. When you have unrelated tables, you cannot create visualizations from this data source. So every table in this data canvas has to be related to each other. GDP, population, and life expectancy all have the same year column and also a country column. We're going to use these two common columns to relate these tables to each other. Once I specify year and country as columns, you see the relationship is established. I'm going to also relate this to the population table as well, using the same columns as relational columns. Here add another relational field, year, in addition to the country column. So all three tables are related to each other. Now we can start creating visualizations. We're going to start by creating a visualization by going to Sheets. Tableau tries to extract the data from the data source by applying series of data transformation we specified to get the data ready for the visualization. I'm going to name this sheet scatterplot because that's what we're going to do. We're going to replicate the Gapminder scatter plot. So we need life expectancy. I'm going to drag this life expectancy to rows and GDP number to columns. Then you see a scatter plot. There's a single dot here because it represents the whole data set, aggregating all the numbers across the years and across the countries. To break this circle into country level, you drag country into detail, and that will basically divide the data into different countries. So each circle represents each country in this case. We further need to break this data into multiple years. You first drag year to filters. You can select the years that you are interested in, or instead you can reify this filter on the right panel where you can interactively select years you are interested in. In the filtering checkbox, you can select multiple years, but that doesn't really make sense. So we're going to change the representation to slider. Then you can only select a single year at a time. In the slider, you will see that it has future years based on the prediction model. But that's probably not what we want. Let's filter those years. If you go back to the data source, you could add a filter that applies to all the tables because they are related to each other. I'm going to just choose the year from the life expectancy table. Go to the condition and use the formula. Then we're going to only consider years that are less than 2025. Hit OK and the filter is applied. If you go to the scatter plot again, the year slider seems to be updated. If you scroll to the right, you see that it only goes up to 2025, which is the maximum that we specified. We need to add one more thing. Population is missing. We're going to drag this population to size to map the population to the size of the circle. You can also click this size and increase the circle size as well. You can also swap the axis if you want, or change the aspect ratio of the chart to make it more responsive, or just use the standard size. You can also, rather than using a hollow circle, change that to a filled circle. So we are almost done with only a couple of things remaining. If you look at this outlier, Monaco seems to be kind of weirdly larger in terms of GDP compared to other countries. You can click the mark to exclude it from the chart. To make it more flexible, you can actually visualize this country filter. Then you can kind of see all the countries that you can select in order to remove from the visualization. If you recall the original chart, there was a continent variable where the countries are divided into multiple continents. Gapminder offers the underlying geographic mapping table. We're going to use this mapping table to map the continent to color. Let's go back to data source. Instead of loading this as another table, I will show another way of integrating multiple tables. The main data canvas is where you logically relate data tables. When you double-click to get to the physical layer of the table, we can manipulate or change the underlying data. We will modify the life expectancy data by integrating additional continent metadata from the mapping table. Once you drag the mapping table into the physical layer of the life expectancy table, it will show multiple joining operations that you can apply. Joining is done by the common column between this life expectancy table and the continent mapping table. In our case, it's country. So we're going to use the country from the life expectancy and the name from the continent mapping to join the two tables together. So now you've successfully inner joined the two data tables. Inner join means that you are basically only using the intersection between the tables. On the other hand, the left join means you're going to keep everything in the life expectancy data table and bring additional metadata from continent mapping. the right join is basically the other way around. You use the continent mapping as the base table. The full outer means that you keep every row even if there is no match between the tables. You even keep the rows as is. You basically don't lose any data set here. But in our case, we're going to just use the inner data set, which means we're going to only consider countries that have this metadata information. Going back to the logical data canvas, you will see this little icon, which means this table is basically generated from joining multiple tables. If you go to the scatter plot and look at the life expectancy portion of the data table, here you see the additional metadata that you join inside the life expectancy. So we're going to use the 4 regions as 4 continents. We're going to map that to color. Then you see, the resulting chart is basically what we saw from the Gapminder website. From this scatter plot, you can select countries like China and USA. And then if you change the slider, you can kind of keep track of how they are changing over time. All right, that's the end of this demonstration.